continuing on with chapter 17, this is page 464. We classify smog, air pollution, in two ways. One is called industrial smog, and you can see it's gray in color, and it comes mainly from power plants or factories that burn coal or oil. So a power plant, again, is something that makes electricity. A factory runs machines to produce items. The main pollutants from factories and power plants is sulfur dioxide, particulate matter, carbon monoxide. You need to memorize that these are the ones more likely from burning coal in power plants and other places. Over here, we have photochemical smog. So this is the type of smog that we have here in Santa Clarita and in Southern California and Los Angeles. So the word photo means light. Think about photosynthesis, uses light. We call it brown smog because it is brown in color. You can see the picture there. It's brown in color. It's mainly from transportation like cars. The main air pollutants are NO2 or NO, so NOx, NOx, ozone, FOx, and hydrocarbons. So these are the four main ones from automobiles and photochemical smog. Photochemical smog is worse in summer because there's more light, because we have more daylight in summer. We learned about that earlier in this chapter, because we're tilted toward the sun, so we have more light, more heat, which creates FOx, and more inversion layers in the summer. We hardly have any of these things in the winter. And so right now in the winter in Santa Clarita and LA, our air is great. We have really good air quality in the winter because we don't have light, heat, and inversion layers. So even though we're still driving all our cars and we're still emitting all of that pollution, it doesn't create as much problems and as much secondary air pollutants like ozone. Now, other places in the country have worse air pollution in the winter because they're burning more coal or oil for heat, or wood too. Like Phoenix, Arizona has air pollution days, no burn days, because a lot of people burn wood in their fireplaces for warmth, and it ends up polluting their air a lot. All right, you can turn a couple of pages to page 468. One of the things that's kind of nice is that California emissions are the lowest because, emission limits are the lowest, so which means they're the best. So we can emit the least amount legally. Because, well, okay, so it's good that our emission limits are the lowest. The bad part is that it's because we have terrible air and we violate the Clean Air Act all the time. So smog checks, the reason why you have to get a smog check every 2 years on your car is because it checks how much air pollution you are emitting, and it's a way to lower emissions. So with air pollution, you need to know that tropospheric ozone is bad and stratospheric ozone is good. So ozone functions in a couple of different ways. In the troposphere, it is an air pollutant. It causes respiratory problems like asthma. And in the stratosphere, it's good because it protects us from UV rays. It's the same molecule. They're both O3, O3, but in the stratosphere, we're not there breathing it, so it doesn't cause us any trouble breathing. It protects us from UV rays. Okay, so now that we've cleared up ozone, let's talk about ozone depletion and recovery. This is the third section in chapter 17. So stratospheric ozone thinning is also called the ozone hole, and it's caused by something called chlorofluorocarbons. You can just think of them as CFCs. this is the real chemical formula, but most in our class we just call them CFCs, chlorofluorocarbons. They take the O away from the O3 up in the stratosphere, which is not good. So these chemicals do this. So what happens is that ozone layer is gone, which means more UV rays enter the earth, which causes skin cancer, crop damage, which costs money, productivity of the ocean's plankton decreases. You can also add here, for humans, it can cause cataracts in the eyes. So you should write here, also causes cataracts. I'm writing it very lightly here. But that's something else that UV rays do. Sorry, these UV rays cause all of these problems. So where did these CFCs come from? Well, they were found, they're banned now, but they were found in refrigerators, aerosol cans, and air conditioners. They were a coolant. They made refrigerators cold, etc. In 1987, we realized that we were depleting the ozone layer, and so the world came together in an international conference called the Montreal Protocol, and they decided to go ahead and ban CFCs. This was considered the best environmental success story that we have. It's a way that we can cooperate internationally to solve an international problem. So here's how it works. So here's the chemical formula of how it works. You don't actually need to know this. At one point, the AP test expected you to know these equations, but they no longer expect you to memorize these equations. However, you need to know the process. So ozone, UV breaks it apart. Naturally, this is how it's made. So up in the stratosphere, this is natural chemical formation of stratospheric ozone. UV breaks it, then it reforms, yada yada. This is how CFCs destroy stratospheric ozone. So the CFCs come in with UV rays, it breaks it apart. This free chloride atom forms with O3 and breaks it apart. And so this is how the ozone depletion works up in the stratosphere. Okay, but you do still need to know these next two sticky notes. So what do you do with these? You can write them down or not. It's up to you. You do not need to memorize the formulas anymore, but that's it. Everything else you still have to know. Down here, you still have to know this. So the ozone hole damage peaked in 2009, 2010 because even though CFCs were banned in 87, they take about 25 years to rise up into the atmosphere, into the stratosphere. And so after we went through those 25 years of all those CFCs before the ban going up there, we had all of this peak and damage, and now it's repairing itself, so that's good news. The ozone hole is actually worse in the Antarctic spring, which is September. So they're in the southern hemisphere. So it means their seasons are opposite of us. So in June, July, August is their winter. All right, so ice crystals promote CFCs taking oxygen atoms. So in the winter, you have all this ice, and all winter long, the ice crystals in the atmosphere are causing this reaction up here to take place. It promotes it. So natural ice crystals promote this process. So at the end of winter, you have the least amount of ozone layer. So that would be September at the end of their winter. So it's starting into spring. All right, so you have to know that part. Turn 3 pages to 473. So that's about it for ozone hole that you need to know. Let's go on to acid rain, which we call acid deposition. So acid deposition is any kind of rain, snow, sleet, or even particles like dust that are acidic. And that's why we call it deposition, which means depositing on the ground. So, think of it as acid rain, but it's really all kinds of acid things falling. Coal makes the biggest acid rain, but you also have some from NO2 from petroleum oil. So most of our acid rain, again, comes from burning coal. Some of our acid rain comes from burning NO2 from petroleum oil. Here's the problems, a whole list of problems. So it dissolves marble on limestone in statues and tombstones and buildings. So I was just in Europe, and they have removed some of the works of arts that are statues on the outsides of cathedrals, and they've moved them indoors and replaced them with replicas. So the outside of the cathedral still look the same, but the original art, which a lot of it was carved by really famous artists, have been moved indoors to protect it from acid rain. It changes soil chemistry. It elevates aluminum in the soil, which hinders water and nutrient uptake. So that's like a really specific thing that you have to know. Now, because it's more acidic, the pH of lakes drops, which can harm certain organisms that don't like that pH. Crops get damaged because it doesn't like that pH. It increases heavy metals in lakes and ponds. So the more acidic the water is, it promotes the heavy metals and things coming out of the soil into lakes. It decreases the ability of forests to withstand cold weather, so they can't, withstand cold weather. So mitigation means, how do we fix it? So how do we fix acid rain? That's what mitigation means. Adding calcium carbonate to ponds and lakes and soil. So back east is where they have most acid rain, not so much in California. So back east, they can add limestone, which is calcium carbonate, to ponds and lakes and whatever to help raise the pH back up. To reduce SO2, we can put wet scrubbers on coal power plants, which will reduce SO2, which lessens the amount of sulfuric acid produced. So the two types of acid rain is sulfuric acid from SO2 and nitric acid from NO2. Okay, so page 474. Water buffering is a chemistry definition that you may or may not remember, but it's the ability to maintain pH with the addition of acid. And so some places have natural buffering. So some places in their soil and bedrock have things like limestone. Oh, I wrote limestock. That's actually limestone. So change that to limestone, not limestock. So limestone bedrock neutralizes acid rain. So we can add limestone, calcium carbonate. So limestone's calcium carbonate. We can add it, but some places already have it. And so if they're going to have acid rain, they're not going to change in pH very much because they already have limestone in their bedrock. And so some places don't get influenced by that as much. Okay, so acid rain mainly affects homes downward from coal burning power plants, but it also can travel to other states too. Here's the equations. You do not need to memorize these equations. You used to have to memorize these equations. You don't anymore, but those of you who like chemistry can see that creating sulfuric acid is a two-part equation, and then creating nitric acid is a one-part equation. And this is from burning coal, this is from burning oil. So you can choose to write this or not. Everything else is mandatory, but you do not need to know the equations anymore. Okay, up here is a picture, this is page 475, of where acid rain is most prevalent. And you can see we've done a huge amount of improvement since 1990. So the Clean Air Act in 1990 set limits on sulfur dioxide, which creates sulfuric acid, and we have lessened our acid rain a lot. And we don't have it very much over here on the West Coast. So that's one thing we don't have. We have a lot of smog here in LA, but we don't really have acid rain, so that's nice. All right, so I'm going to talk about indoor air pollution, which is the next section in the next video.